everyone. My name is Bill Chestnut, and welcome to the April meeting of Integration Down Under. Let's see, we've got a few attendees on the call already, so we'll go ahead and get started tonight. So we have just a couple of slides to go through. The organizers, this is basically our Martin, Dan, Renee, Wagner, and myself. And also, you might have seen we have added a website finally. We now have our Integration Down Under website, and it has the next webcast on it with the details about it. And it also lists all of the previous YouTube recordings from our the meetings we've had so far. And it also gives you a link to subscribe to those. So that's just giving you a little bit of a look at the website we've got up and going now. And we do have some stickers. I don't have a picture of them at the moment, but we're going to be organizing for a way for people to send us an email and get a sticker for our Integration Down Under. So tonight we have Dan Toomey presenting. He's a Microsoft Azure MVP and Senior Integration Specialist for Deloitte. And it's building event-driven integration architecture with Azure Event Grid. And without any further ado, I am going to hand over to Dan. So let me just change the presenter real quick. And you have it now. So I'm going to do one thing. I just want to make sure that everybody can hear me. And then in a second, make sure that they can hear Dan. So if somebody just wants to hop on the, say, the chat or the question window and just type in there quickly to make sure, yep, all good. Okay, very good. So I'm going to mute my mic and let Dan have it. So thank you very much.
Can you see the title slide?
Yes, I can see the title slide.
Awesome, fantastic. Okay, well, good evening, everyone. And yeah, thanks for this opportunity to present tonight. I'm going to talk about event-driven integration. And just moving ahead. So Bill's already introduced me, so I'm not really going to say very much, except that I work for Deloitte as an integration specialist. Previously, before that, I worked for Mexia, which many of you might have heard of if you're from this region. And I've been in the integration space for probably about 15 years when Bill taught me how to use BizTalk back then. And actually, to be fair, it was Mick Badron who introduced me to BizTalk, but Bill came along shortly after and showed me how to get around some of the stickier bits that we had issues with at a client. And Bill's been my mentor ever since. So there's my details if you're interested in finding out any more. So as I said, tonight I'm going to talk about events. And as IT professionals, most of the events that we're concerned with are not quite as dramatic as this one. And I have to say, that's a pretty spectacular picture. I don't know how many of you are aware that with volcanoes that you can actually get lightning associated with that volcano. And it basically arises from the colliding fragmented particles of volcanic ash, which generate static electricity. So that was something that I learned pretty recently and thought it was pretty cool. But basically what an event is essentially it means that something has happened. And as I said, not always as dramatic as this, but it, in the IT world, it could be somebody clicked a button or a file arrived, was created in a directory or something similar. The important thing is that the event's not much of an event if no one is actually interested in it. So I guess it comes back to that sort of same age-old question about if a tree falls in the forest and there's no one to hear it, does it make a sound? So the idea is that someone somewhere is interested in that event and they want to get a notification of that event occurring. And the reason they do is because typically there's some sort of a reaction. There's something that gets triggered by that event happening. Events are based on facts. They're based on, some very metadata around that particular occurrence of whatever it is, but it doesn't necessarily carry a lot of data. And I'll talk about this more later when I describe the difference between events and messages, or eventing and messaging. So for example, if a file is written to a directory, then the facts about that file are, you know, when was it written, how big is the file, what's the name of the file, what's the file type, that kind of stuff, but not necessarily all the data that's in that file. So events can be discrete or series-based, and I'm going to describe that now for you. So discrete events are events that are of interest in themselves. So a single event happens and it's substantial enough for you to react to it. For example, a file is created or somebody clicks a button on a Windows form. And that means it usually reports some kind of a state change, and it means that you can base an action or a trigger or something on that single event. That contrasts to series-based events where the single event in itself may not be significant, but that you actually need to have a series of events to then recognize a pattern. For example, when I present this live, I usually give the example that if the temperature in the room hits 25 degrees Celsius, that's probably not a very significant event in itself. But if in the next few seconds it reaches 27 degrees, and then a few seconds later it reaches 29 degrees, that actually becomes significant because the series of events is telling you that the temperature is rising in the room. And that's the kind of thing that might, you know, trigger the air conditioner to come on. Or if it hits, you know, 35 degrees or 40 degrees within a few seconds, and it means maybe you should call the fire department. So series events are basically time-based, where order is important. You actually analyze that sequence. So therefore, there's a context partitioning around that. There's a window of events that you need to perform that analysis on. And they typically report a condition, and the series of events is analyzable. So you might be feeding that series of events into something like stream analytics, for example, so that you can actually execute the algorithms that will make that information of significance. So there's an article here. Actually, it's a presentation that Clemens Vasters gave at Integrate last year in London, and there's a video which you can watch, and it is an absolutely fascinating talk where he talks quite a bit about the different types of events and also the difference between eventing and messaging, which I'm going to get into soon. I'd highly recommend watching that video. Also, I wanted to describe a little bit the difference between event-driven versus event sourcing. So event notifications, again, this is when an event happens and somebody wants to action that. And with event-driven, the actual event, the source of the event itself, isn't concerned with who's subscribing to it. They just publish the event, and whoever's interested in it can then react. So there's no expectation from the consumer about that, and it's very, very decoupled logic. Whereas event sourcing really talks more about where the eventing is actually the source of the data, and that data is important. So it's important, for example, to persist all those state changes. For that one might be applied in a case where you're doing auditing, and it often means that you need to have some sort of ability to replay those events because there's significance in that. And there's a link there to an article by Martin Fowler that talks about that. So why are we concerned about events when it comes to integration? Well, there's a number of reasons. So APIs today are often rely on what we would call situational data, because there's data all around us. It's ubiquitous, right? We have mobile devices everywhere. We've got IoT, which is capturing data from everywhere, and people want to obviously analyze and react to that. So things, for example, like the temperature in the room example is a perfect situation of that. So those events need to trigger processes to do something, and that's why event-driven integration becomes important. So in this sort of image from Gartner, we can see that there's two kinds. There's a shift here where the first priority as a source of truth is the actual data store, and that's the more traditional approach that we've had. Whereas now in sort of this kind of ubiquitous data world, or where there's APIs, the source of truth is actually the logging of the events itself and the reactions to those events. Another reason is that people expect things to happen in real time right now. So I like to use the example of you get a text message well, first you charge something on your credit card, and maybe you're gone away on holidays and you're out of the country. And the moment you make that charge, suddenly you get a text message on your phone that says, you know, someone has placed a charge on your credit card for this amount. So banks will do this. They have algorithms to monitor what they consider unusual behavior or charging behavior, and they notify you. And they notify you, you know, generally right away. Because if you think about it, how useful would that information be if you didn't get it until the next day? You know, because it ran on an overnight batch job or something like that. So we've come to expect information to be delivered in real time. And that's why event-driven integration is really important, because you get notified as the event happens without having to wait for some other kind of processing to happen. It's also cheaper and more efficient in polling. So we can obviously publish messages, say, to a service bus, or publish it to some data store and have something that actually polls and looks for those events. But there's two things about that. Number one, it's expensive because whoever's doing the polling has to continually do that, whether or not there are any events or notifications to listen to. So there's a bit of wasted effort there. And of course, in Azure, where you tend to pay as you go, that means you're wasting money to doing that. And also, the timeliness of you getting that notification is then dependent upon the interval that you have between that polling. And generally, you have to then strike a balance between, well, how much money do I want to spend polling very, very often, or can I wait, pull that back, but then I wait, you know, potentially wait to get longer to get that event notification. So with event-driven integration, the idea is you actually push events out as they happen, so you get them in real time. And also there's the flexibility and the scalability too of this model. So if you have a publisher that's publishing events and you have, say, two subscribers that are listening to it, and this is the basis of your application. If later on you want to extend that application to include additional subscribers, there's really no impact on the existing part of the application. So you don't have to worry that you're going to break something by doing that. So it makes a model that's very, very flexible and scalable. So I don't know about you, but I haven't had my dinner yet, and that pizza looks really, really good. I like using this pizza analogy here to kind of explain some of the basic messaging models, and I thought I might throw that in here so to lead into my discussion about the difference between eventing and messaging. And there's a link there to a blog post I wrote about this if you want to check it out. And hopefully, I just want to say, with all due respect to grandmothers, I'm not attempting to insult anybody by that article title. So the analogy is that you decide you want to order a pizza, but in order to do that, you need to know a few things first. For example, you need to know that the pizza shop is open. Secondly, you probably need to know what kind of pizzas they have on their menu so you know what to order. So the way you would find that out typically is you either phone them up, or, you know, probably most of us today will just go to their website and find the information there on the website. The thing is about that, you go to ask for that information and you'll get it back immediately. You shouldn't have to wait for that. And of course, it's important that you get that information because you can't really proceed to the next step until you do that. It's kind of a blocking operation. So that is your synchronous model. So that's basic request response, which is one of the simplest messaging patterns to implement. Now, let's say that you've established that the pizza shop is open and you know what you want to order. So you go to place your order. Typically, you would not expect to get the pizza handed to you straight away. If you did, it's probably not a very good pizza, right? Because it's been sitting under a heat lamp waiting for somebody to order it. So what normally happens is you're given like a ticket or a receipt number or some sort of acknowledgement that you've placed your order, and you're probably told it will be ready in 20 minutes or something like that. But the actual pizza is delivered later at a time, and that is basically an asynchronous model. Now, there's two ways that you can do that. You could decide that you want the pizza actually delivered to you. And that's generally a very preferable model because it means you can stay at home and do other things. You know, you can watch TV, have a beer. You don't have to go out in your car and drive anywhere. They'll bring the pizza to you. But in order for them to do that, they need to have your address. If you don't give them the right address, they're not going to be able to deliver it to you. So in the asynchronous world in messaging, we call that a callback, right? You give them a callback endpoint so that the service that's providing what you ordered knows how to deliver that to you. The other option is that you decide you don't want to give out your address for whatever reason, but you want to go to the pizza shop and actually pick it up yourself. So you might drive to the pizza shop. They tell you the pizza's ready in 20 minutes, but you'll get there in 10 minutes and you'll ask them if it's ready. And they'll say, no, sorry, not yet. And it'll be a little bit while longer. And you sit down, and as you're sitting down, you're starting smelling all the wonderful aromas of the pizza's cooking in the oven, and you're getting very, very hungry. So you get up in 5 minutes and ask, is the pizza ready yet? And they'll say, no, not quite yet. So you have to sit down again. And, you know, after another few minutes, you're starting to get a bit hungrier and a bit grumpier maybe, and you get up and say, isn't it ready yet? And they say, look, okay, we're boxing it up now. So that's actually an example of a polling model, right? Where you have to keep asking for the message and whether it's ready. And you'll probably ask a number of times without actually being able to retrieve what it is that you're after. But then finally, at some point, it's going to be there and you can pick it up. So that's the asynchronous polling model. The third messaging pattern I wanted to talk about is by far the most flexible and the one that we really like in the integration world. And that's the subscription pattern, or publish and subscribe. So in this case, you had the pizza, you really liked the pizza, it was delicious, but it was kind of expensive. So you ask the manager if there's any way that you can be notified when he has any kind of sales or special discounts on. And the manager says, sure, what I'll do is I'll put you on a mailing list because I publish a monthly newsletter. Now, the good thing about this is that the manager does the same work every month of creating and publishing this newsletter, regardless of how many subscribers he has. It's no more work for him to have 10 subscribers as opposed to 200 subscribers on his list, you know, obviously, unless he's deciding to individually mail each message, which is unlikely. So that's a very, very flexible model. And it also means that manager doesn't even have to know who is subscribing. Hopefully he has some kind of a self-onboarding, something you can sign up by yourself, and he doesn't have to be aware of who's receiving his messages. All he cares about is getting the message out there, and that someone somewhere is going to receive it. So that's the publish subscribe model, and it's one that we really like. And we do that in messaging, but we also do it in eventing. So the difference between messaging and eventing, and this again was really, really well explained by Clemens Vasters in that talk that he gave last year, is that messaging is about intents. So basically there is an expectation. When the publisher publishes a message, he expects someone or somewhere to do something with that message. And therefore, it tends to be conversational. And because the messaging publisher often knows something about who's retrieving those messages, there's generally a contract that's involved in there. And it can be about, you know, transferring control or maybe just passing values around. With eventing, because eventing is based on facts rather than intents, then really the publisher doesn't really care that much about who's receiving it and doesn't know. And there's generally history involved in that. There's often, if it's series-based events, then context and order becomes important. And also with the schema, the eventing is published with obviously some sort of a schema, and it's the responsibility of whoever is going to receive those events to be able to interpret that properly. And that's a problem which I'm going to talk about a little bit later. So looking at these patterns, in the messaging pattern, you say you have these three participants, and A is the publisher. As you can see, there's probably, you know, some two-way communication in certain circumstances, and because of that, A actually knows who the other recipients of the messages are. So in this case, it knows B and it knows C. In the eventing world, A is just actually spitting out these events and doesn't really know necessarily who's ingesting them. And you can see that it is definitely like a one-way type of communication. So I mentioned before about schemas for events, and there is an organization called the Cloud Native Computing Foundation that's actually working on solving this problem by trying to create a non-proprietary schema a standard for how to describe cloud-based events. So this is currently in process, and you can actually contribute to it if you want by their open collaboration on GitHub. So I've included that link there. And this is starting to become a standard. It actually is. It's actually been embraced by Microsoft as well. So as an example here, the schema that they've been working on, you can see that with the events, there's a certain amount of metadata that goes with that event. And for example, you've got a unique ID, and you've got an event time, a timestamp. You've got a version for the particular schema that they're using, which in this case is 0.1. I hear the 0.2 might be out by now. And then you have a few other things, like for example, the event type, so that people know how to subscribe to it, and the source of where that event is. Then there's the data is actually where the payload of that event, and that's whatever needs to carry with it, and the content type simply describes how to read that data. So in this case, it would be text XML, but it could be anything. There's also an extensions attribute where you can actually put in your own key value pairs that might be significant, and that obviously creates another mechanism by which your subscribers can filter on events that they happen to be interested in. So an example scenario where we might have eventing or event-based integration is that, let's say that you have an application which is publishing logging events. And those events are picked up by a topic, which then sends them via a handler that subscribes to it to be persisted into a data store somewhere, so that someone can look at those logging events later when they need to do some troubleshooting. But you also might want to have a different handler that subscribes to events that are error events, because in this case, somebody might need to be notified that something's wrong with your application. So this handler might be pushing out, something to people's pagers or to their mobile phones by SMS. You also might have a subscriber for warning events, which maybe pushes it out in a little less intrusive way, like say by email, because they're not quite as urgent as the error messages. So here's an example of event-based integration and how that might work. Now, the only problem with this is that presumably in this model, every single error is going to wind up pushing out an SMS, depending, I guess, on the logic that you have in your handler. That could involve a lot of spamming and probably really annoy somebody after a while if you have, say, an endpoint is down and you're constantly getting the same error. So we might tend to look at this as a series-based eventing rather than discrete events before, and do something like put, say, stream analytics in there, where now we're really only interested if we get a certain number of events within a certain time interval, and then we'll push out a single SMS message. So this is the example here between discrete and series-based events. So just mentioning a couple of different eventing platforms that are out there. Besides Microsoft, of course, you have Apache Kafka, which Kafka is not a serverless option, so it's you actually have to set up your own cluster to run that, but you have the option of running that in the cloud or on-prem. AWS has Kinesis, which is for streaming events. That does operate only in the cloud, obviously, with Amazon, and it's optimized for big data processing. Solace is another product that I came to learn about last year, which is also about event distribution and messaging middleware, and that can run on-prem or in the cloud, depending on how you want it. So there is a managed offering for that as well. And then finally, we get to the Microsoft offerings, which is Azure Event Hubs and Event Grid, and that's the ones I'm really going to talk about most here. So with Event Hubs, basically this is an event ingester, and it's designed for big data streaming. And essentially, it gives you a partitioned model in it, so that you can create different partitions for different kinds of events. And the thing about Event Hub is that it has the ability to replay the messages. So you can think of it kind of as a big tape recorder. So you have the ability to do that. There is an archive feature in it, and it also has the capability of integrating with Kafka. Unlike event hubs, Event Grid doesn't have that ability to replay messages, although there is now an archive option in it. But Event Grid is more about reacting to events rather than doing analysis. So event hubs might be really good for doing your series-based events where you need to put some analysis over them. But Event Grid is probably more suited to just having that sort of reaction to events as they're published. And the great things about Event Grid is that it works natively with a whole lot of different Azure services. So it's extremely easy to actually plug in to Azure at a number of Azure services and capture events. And I'm going to show how easy that is in my first demo tonight. It's very scalable and resilient, just like event hubs, and it actually works as a push model. So when it receives events, it actually pushes it out to its subscribers. And those subscribers include a number of other Azure services, but it also can push out to webhooks, which means you can essentially send an event to anywhere, anything that can publish a webhook. So it's not a polling situation, it actually pushes it out. Also, I'll note that in the event sources, you've got custom topics as well. So you don't necessarily have to be an Azure service to publish to Event Grid, but you'll have to conform, of course, to a schema that Event Grid can understand. So the benefits is that of Event Grid is that you can it's a serverless feature, so you pay for event, you pay as you go. You don't have to worry about scalability; it does that automatically for you. It's extremely reliable. I'll talk about that in a second, and basically allows you to create event-based serverless applications. And the great thing about Event Grid is you can manage all your events in one place. So in terms of reliability and performance, the performance target is that 99% of events will be published in sub-second. So we're talking in microseconds there. And it's massively scalable. It's designed to handle 10 million events per second per region, which is, that's an awful lot of telemetry. And with the retry capability, it will retry delivering events to your subscribers for up to a 24-hour period. And it does that with an exponential backoff. It also does it with a little bit of randomization so that if you get a whole lot of events coming out that are failing, rather than just retry them again 5 seconds later, all at the same time, it actually does spread them out a little bit just to kind of prevent that bottlenecking. So I thought I might just point out a little bit the scale of how messaging is working in Azure. Basically, with Event Grid, they're getting about 1.3 petabyte of data ingress per day and 2 petabyte of data egress. So that's an awful lot of data that's coming out. That's basically also 2.2 trillion requests per day. In case you have trouble reading that big long number. And their success rate still with those staggering numbers is 99, it's almost 6 nines, which is pretty impressive, even for Azure services. That's a pretty impressive SLA on that. But what does that really mean when you have that many requests? I mean, what does 6 nines actually look like? So if we consider that we're getting 2.2 trillion requests and we're getting almost 6 nines of success, how many failures is that? So I point this out because it's important to realize that when you're building your applications, you do have to design them for a little bit of resilience, right? And there's an expectation there that you may have failures, and you have to handle that. I mean, that is a pretty staggering number, even at that success rate. From a security perspective in Event Grid, basically with the publishers, you have 2 options. You can do a key authentication just using a header, but the preferred option, of course, is to use an SAS token because the SAS token is, shared access signature, gives you the ability to define an expiration on that in a signature. So it's generally a fairly accepted form of security and authorization. It's used a lot in service bus and elsewhere, storage, for example. As far as the creating a subscription, there's role-based access across pretty much everything you do with Event Grid. So for the publishers, there's role-based access for that, and for custom topics as well. And then as far as management, again, there's role-based access as well. That's fine-grained for setting permissions for read, write, and delete, and a few other things. And there's a link there if you want to find out more about how security authentication is done for Event Grid. So here's an example of a message or an event with using the Event Grid schema. So this is Microsoft's proprietary schema. And you can see that you have your metadata, which is the topic, the subject, and the event type, the event time, and a unique ID. And then you've got your data. Now, this particular event is when a blob is created in a storage account. So this schema here is basically how Azure blob storage defines its event when a blob is created. And you can see it's all very factual stuff. It doesn't contain the contents of that blob, but it does tell you a few things about it, like what the content type is, what the size of it is, obviously where it is, those kind of things. Now, you can also create custom events as well. So this would be an event that somebody created to, monitor cryptocurrency. And you can see in this case, the data just has a single field in it. When I get to my demo, I'll actually show you the difference between Microsoft's event schema and the cloud event schema, which is the more standardized non-proprietary version. I just wanted to mention a fairly new feature that Event Grid has, which is called event domains. So event domain gives you a little bit more control of your publishing and actually segregation from a security perspective. So if I can describe how this might work, let's say, for example, that you have a company like Contoso Construction Machinery that manufactures tractors and digging equipment and other heavy machinery. And they need to push real-time information to their customers regarding equipment maintenance or systems health or contract updates. So all of this would go to various endpoints, including your app, the customer endpoints, and other infrastructure customers had set up. Event domains gives you the ability to model this with a single eventing entity, so that you only have to publish to that one entity, whereas each of your customers is represented as a topic within the domain, and it handles authentication and authorization using Azure AD in each one of those domains. So the advantage here is that you can secure each one of those and ensure that customers only get the events, or are only allowed to receive and filter on events that they're entitled to receive, while you're still publishing to a single endpoint. The last time I talked about this with somebody, they asked to explain the difference between some of the three big sort of messaging or eventing platforms in Azure. So just for clarity here, Service Bus is really about messaging more than it is eventing. So it's usually conversational, and usually you want it to be very robust and have a lot of control around it. So if you need to support transactions, or you need add-on features like deduplication, or maybe event, message forwarding, or even message deferral, then you should probably use Service Bus. So if you're handling financial stuff, financial transactions, I would definitely be using Service Bus and not Event Hub or Event Grid. Event Hub, as I mentioned, is about streaming events. It's really designed for big data. And it's great when you want to have that replay capability or do analysis over series-based events. Whereas Event Grid is designed more about handling those events. It's a very, very reactive kind of model, and it pushes all of the events out to its subscribers. So that link there will give you a tour of all of the messaging services, and not only these three, but quite a few others in Azure if you want to have a look at that. So now it's time to have fun, and I'm going to launch into my first demo, and I'm actually going to be brave and try to actually build this in front of you to show you how easy it is to integrate Event Grid with existing Azure services. So the scenario here is that you have a storage blob and you want to react to files being created within that blob storage. So Event Grid can subscribe to those events, And we're actually going to create 2 subscriptions, one that's based on file extension of JPEGs and the other with the file extension of PDF. And because it's just very easy to do this and actually see the results, I'm just going to use a webhook, which is actually going to be a request bin. So let me just change my screen. Okay, so hopefully you can see the Azure portal here, and somebody let me know if you can't. But
Yeah.
what we're looking, you can see it?
You can see it then, yep.
Awesome, thanks. Okay, so this is basically blob storage that I have set up. In there, there is a single container called test container. And right now that container is empty. So there's nothing in it. Now, if I go back, oops, sorry, I just shouldn't have closed the account. If I go into the blob storage, you will notice that we have this events tab here. And this allows you to set up a subscription to events that are associated with this blob storage account. So we can create a new event subscription. And this is basically underpinned by event grid. So I can give this a name. So I'll just call this IDU, and we'll call this JPEG because that's what I'm going to be subscribing to here. And I have a choice between the event grid schema, which is obviously Microsoft's proprietary schema, or the cloud event schema, which is becoming a new standard. Or I could actually create my own schema if I really wanted to. We'll just use event grid schema for this one. We use this storage account. I can subscribe to all events, or I can just limit it to say Blob created if I want to. And then I choose the subscriber type, the endpoint that's going to receive them. So I have a choice of sending it to a storage queue or to event hubs or hybrid connections. I'll choose just webhook in this case. And now I've got to select an endpoint. So I'm just going to go to request bin here and generate a new endpoint. Here we go. So I'll copy that. And then we'll paste that in here. Okay, and I'm going to confirm the selection. Now, I also have the ability to set up filters on this account. So I can enable subject filter. So the subject is going to be generally for a blob storage event, it's going to be the name of the file that gets created. So in this case, I can choose either begins with or ends with. I'm going to be interested in files that end in JPEG. And I could even make that case sensitive if I want to. In this case, I don't really need to. I also have the ability to create advanced filters if I want. So I can create keys based on any of the other metadata items like the ID, the topic, or the event type. Or I can even do it based on a field in the data, provided that data level field is at the top level of the data. So I could choose something there. And you see I have all different conditions I could use to match that. I'm not going to bother doing that for this one. Other additional features I could do is I can enable dead lettering. So there is now dead lettering support in Event Grid if in case something can't be delivered. I can actually configure retry policy. So the default is for it to try up for 24 hours. But because I actually pay for every one of those retries, I may decide, for example, I want to limit the number of retries. Or I might also give events a certain time to live if I know that, you know, let's say after 10 minutes, it's not even valid anymore. So that gives me some ability to do that. And I also can have the entire subscription expire itself, which means it'll delete itself after a certain period of time. So with that, I'm going to go ahead and create that. Now, as it goes and creates that subscription, and it doesn't take very long, we're going to see that our first event is created. Now, I'll just refresh this screen, and there it is. We can see that Azure, because I've chosen a webhook, Azure Event Grid wants to validate that that subscription is actually a valid URL, that we have access to it. So it sends a subscription validation event to it. And we can see again the structure of that event with its metadata, and in this case there actually isn't really any there is a bit of a data payload here. It's the validation code and the validation URL where it needs to send something back to. So we've got that first event. Now I'm going to go back, and here we see that our event description has been created. I want to add a new one. So we're going to do pretty much the same thing, except this time I'm only going to listen to PDF files. So we'll call this IDU PDF. And this one I'll also use a cloud event schema so we can see the difference between those two. And I'll do a webhook again. Fine, select an endpoint, and I have another request bin page here where I'll create a different URL. Paste that in, confirm selection. And we just need to set a filter on this one, and this one we want to set to .pdf. There we go. All right, we'll go ahead and create that one. And when we refresh this, we should see a new event in there. We do. There we go. Okay, also a subscription validation event. So now all that's left to do is to actually send some messages. So for that, I'm going to use Storage Explorer just because it's the easiest one to actually upload files. And I'll just need to get to my folder, which I'll pull over here. So I'm going to add a JPEG in there, and we'll see that created in just a moment. Should see it created. Oh yeah, there it is, Dan, JPEG. Okay, so now that we've done that, we should have a new event in this request bin. And we do. So unfortunately, it doesn't pre-print it. So what I'm going to do is just copy that whole thing. And sorry, I probably should have had this set up in advance. I'll paste this into Visual Studio Code, and yes, I'll bring that to the screen in just a moment. So new file. I have to save it though, as otherwise I don't get the. So we'll save this as. Sorry, this will just take a second. Save as. Okay, and then I can format that document. Okay, so let me pull this over here so that you can see it. This is the event that was created, and you can see it looks an awful lot like the sample that I showed you in this slideshow. So the event type is Blob created. You've got your metadata here. You've got the topic, which itself, which is the actual event grid topic, and your data about that blob, including the content type, which is JPEG, and the actual URL where that's created. And this is using the event grid schema. So I'm just going to, is there a duplicate? No, there isn't. Okay, I'll just create a new file and we'll save this as, so when I do the next event, it'll be easy to paste in. We'll save this as a JSON file. Here we go. Okay, save. So what I'll do now is I'll go back to my Storage Explorer and I'll upload a PDF file. There we go. So that PDF file is there. And just to prove that in this particular request bin, if I refresh it, we are not going to get an event associated with that PDF. So no new events have come in. But in the other request bin, we should see that file creation event, and there it is. So I'm going to go ahead and copy that, go back to my Visual Studio Code and paste that in there, then just format the document. Now, with this one, remember I created this with the cloud event schema. So we can see that things are a little bit different. You got your cloud event version here. And here's the other one that we had, which has a slightly different metadata fields in it, but it's essentially the same idea. And we still have our data element, and we still have the same data in that put blob schema with all of the same information. So you can see that it only took me a couple of minutes to actually just create an event-based integration here using Azure Event Grid with Azure services. Now, obviously, if I wanted to do custom events from a service outside of Azure, then there would be a lot more work to do that, because I'd have to actually write the code to publish the event to the to an Event Grid web endpoint. But you can see how powerful that is. Right. So let's get back to the presentation. So that was that demo. Now I wanted to do a slightly more sophisticated demo, and this one I'm not going to game to build in front of you, because I don't want to have you sitting there all night while I write a lot of code. But the premise of this demo is a little bit more complex. Let's say that you're a developer working at a company, and your organization has given you an Azure VM to do your development on, but you're finding it's a bit slow, and you get tired of waiting for compile time, and Visual Studio is loading very slow and all of that, and you go in and look at the specs of the machine, and it's not really quite up to what you think it should be. And because you've been given access to that machine in the portal, you decide you want to upscale that machine a bit. So you create a different size and double the memory and stuff. Now, the problem is that the project manager, in this case, has a very limited budget on the project, and he doesn't want his developers going and creating more expensive virtual machines. So this application basically is designed that every time some change is made in the resource group for the VMs, it publishes an event to Event Grid. An event takes that event and it pushes that out to a logic app. Now, the event itself doesn't contain the new size of the VM. It contains information that something has changed and about what has changed. So it has all the information, the metadata about the VM and where it's located, but not what its new size is. So the logic app uses an Azure function that goes off and queries that VM to get the new size. So remember I said that events are about facts, but they're generally very limited. It's not messaging. So in this case, we had to go and use the information from that event to go and get more information. Once it knows what the new size is, it uses another Azure function to call off to a table in table storage that has a list of all of the valid sizes for VMs, the ones that are approved for use in the project. And then it checks, does a comparison to see whether or not that matches what the new size is. And depending on the outcome of that, it sends a message out to the administrator to say, hey, your developer has changed its VM configuration, and it may not meet exactly what you're budgeting for in your project. So that's essentially this demo. And if I go back to our Internet Explorer, so what I've got here is I've got the logic app, and I'll just kind of walk you through how that is by going into the designer view. So Logic App has a trigger in it specifically for Event Grid. So we can use an Event Grid trigger. And in this case, I'm monitoring a particular resource type, which is my virtual machine. So I give all that information there. And I'm interested only in the write success events. So I'm not interested in reads or any writes that don't succeed. And this is the name of my subscription that I've given to it, which is going to be an Event Grid topic. So that's actually pretty straight ahead. I set that up initially. I then make my call off to the function, giving it the subject, because the subject of the event that comes out of here is going to be the name of that virtual machine and how to access it. So that function then comes back with a result of true or false on whether, well, no, actually comes back with a size, sorry, which is in the body of that message. And I'm sure you know how logic apps work right now. You've got dynamic content, where you can choose data that comes from previous shapes, previous actions. So that passes the body off, and it calls off the table storage to find out whether or not that's an approved size or not. And then based on whether it's approved size, we send an email, and the email is either notification method where, yep, it's just it's a low priority message that says, yep, it's been upgraded to an authorized size. Or if it isn't an authorized, it has a high priority message that says, hey, this is not an authorized size. And we use the dynamic properties to give some information in that email message. I can also just show you briefly the functions that are involved in this. So the get Azure VM size is actually a PowerShell function because I found it was easiest to write that in PowerShell. It's I think PowerShell is still a preview language in functions, but it's been around for a little while, and I don't know why that's taking so long to load the code. But essentially, that goes off and queries the VM size and returns that. Yeah, if that takes too much longer, I might just move on. Obviously, it needs to something needs to warm up there. It looks like it's coming. Yeah, basically. So because the string that comes in is a big long URL string to that resource, then I've had to do a little bit of finagling around here to actually parse out the name of the VM. And then from that, I just usually I use the get Azure VM PowerShell commandlet to go and query that size. For the is approved VM size, that's simply a call off to table storage, and then just a query to see whether or not the size that comes in for that VM is actually found in that table. So let's see it in action. So what you don't see, which I might have to pull into, I'll pull into view when it comes up, is my mail account, which is going to get these messages. So just do this. I'll get that set up so that's up and running. Hang on a second. Sorry, what is that doing? Okay, so what I'm going to do is I have got my VM here, and the size right now is a D2V2 size, which has only got 7 gig of RAM. And I'm deciding that's not really quite fast enough for what I want to do. I need to double that RAM size. So I want to choose this size, and I'm going to go and resize it. And that operation actually happens pretty quickly, especially when the VM's not running. So I'm just pulling my Outlook box into view here. And what we hope is going to happen is that I'm going to get an email very, very shortly that tells me that something has changed, and we're going to find out whether or not that particular VM size that I picked is actually a valid VM size according to what my project manager's budget. And maybe while we're waiting for that to come in, one of the great things about Logic Apps is that you can actually view actually what's, oh, I didn't mean to do that. Okay, sorry. I always wind up closing the wrong blade. What we want to do is see that something ran. So we can see here on the 11th of the 4th, that's today at 7:53 p.m. That ran, and we can actually go and look at what occurred in that Logic app when it ran. So we can see that it all went through successfully. It successfully executed all these branches, and it went down the false branch. So we know that this was not a valid VM size that we chose. And lo and behold, I've got an email waiting for me that tells me that someone has made an unauthorized VM size change, and there's all the information about it. So our integration has worked. And if I want to prove that it works in the other direction as well, I can trigger by going back and putting the VM, and this is generally what happened after my project manager thanks me for doing something unauthorized. I'll go back and reset it to the normal size, and I should see an email come in as well that tells me that that worked. So that email should come in shortly, but I think what I might do at the moment is just go back to the slide deck and finish off the show. Okay. Sorry, I'm just getting my Windows to do what I expect them to do. Okay, so that's pretty much the wrap up of my presentation tonight. If you're interested and have some questions that you not ready to ask tonight but want to ask later on, you're welcome to email me, or because my email will be on the next slide, or you also welcome to check out Deloitte. You can email us there to access any of our integration experts, and also check out our blog. We've got lots of really interesting articles. We have 3 Azure MVPs in Deloitte Platform Engineering, and the other 2 guys, Justin Yu and Paco de Cruz, are very, very active on the blogging. So it'd be good to check that out. And there's my contact details if you're interested in it. And I'll just also pull up that inbox, and yep, there we go. I got my second email notification that says it's been set back to an authorized VM size. All right, let's see, are there any questions now?
I'm having a look at the question board. I don't see any questions on that.
Okay.
Oh, here's one. Just a fantastic presentation. Thank you, Dan. Very clear, just the kind of information that I was hoping for.
Oh, that's nice. Thank you.
John. And so thanks everyone for attending tonight. And if you had anybody else that was interested in tonight but couldn't attend, we will have the recording up on the website shortly. So thank you very much. And again, any questions? If not, I think we'll call it a night. Thank you very much.
Thank you, everyone.